Now that we have seen the electron orbital shapes for the s, p, d, and f orbitals, welcome to the Group Garage video explaining how we write down the electron configuration using the periodic table as a guide. In 1869, the Russian chemist Dmitry Mendeleev began to put together the framework for the periodic table. He did so by atomic weight and then grouped the elements, which resulted in the modern table with four distinctive groups. The left side are the elements filling the sharp or s orbital. The middle, or dark blue, are filling the diffuse and d orbital. The right side is the principal, or p orbital. And the two rows at the bottom are the fundamental, or f orbitals. We also have them in periods, principal energy levels 1 through 7. So each spot on the table has a set of coordinates, if you will, in the period, and then the electron orbital and the number in that orbital. As we look at a particular element, we can summarize or identify that element with a particular period, 1 through 7, and the orbital block, s, p, d, and f, and the number of electrons we expect in that block. So let's start with the first element, hydrogen. We find that element in the first period and in the s block with 1 electron. So we can write 1 for the first period, followed by s1 for the first electron in the sharp block. For helium, the next in the table, we would write the same 1 for the first period, but this would be followed by s2 for the second electron in the sharp block. Since this is a noble gas and the electron shell is full, we could write this easily as He for short. If we simply went on to the next row, lithium, we could write the noble gas from the first row, helium, and then use the same process, 2 for the second period, followed by the s1 for being the first electron in the sharp or s block. But now let's stay in period 2 and look at the 6 elements which are shown on the right in the principal or p block. How would we write the electron configuration for fluorine? Well, let's start by highlighting the element in the table, and then focus on all of the elements in period 2 before or to the left of fluorine. Since we've already finished period 1, we know we can write He because we know the period 1 is full. Then, on the left, and we see the s orbitals will have both electrons. So, we write 2 for the period, followed by s2 for the 2 electrons. Follow along in period 2, and we'd see there are 5 elements in the p block. So we write 2 for the period, followed by p5 for those 5 electrons. The next block, the diffuse orbitals, we know has room for 10 electrons, and so each element again has a set of d block coordinates. And remember, the d block fills for one row above where it is shown on the table. Let's see how we would write the electron configuration for nickel. Find the element nickel on the periodic table. Highlight all of the elements to the left in the same period as nickel. Start with the noble gas from the period above. Again, the shell is full, so argon. Start on the left and write the period and electrons for the s block, 4s2. Follow along in the row and write the period and electrons for the d block. It is important to remember that the d orbital is for the one period above where it is on the table, so nickel is filling period 3, 3d8. And there is also the convention that you write the smaller period first, so we would write 3d8, 4s2. Another example, let's follow along in period 4 and highlight selenium in the p block. Highlight all of the elements to the left in the same period as selenium. Start with the noble gas from the period above. Again, the shell is full, so we use argon. Start at the left and write the period and electron in the s block, 4s2. Follow along in the row and write the period and electrons for the d block. D is full, 3d10. And remember the convention of smaller periods first. Finally, the 4 electrons in the p block we write as 4p4. But what about fundamental or f electrons? Let's find dysprosium on the periodic table. Highlight all of the elements to the left in the same period as dysprosium. Start with the noble gas from the previous period. This would be for period 5, so we have xenon. Start at the left with cesium and barium, and we have 6s2. For the F block, we have to remember that it is filling for 2 periods above the position in the periodic table, and that lanthanum most of the time is included in the F block. So we write the period and the electrons for the F block as 4f10. and the lower period is written first. Xenon 4F10 6S2. Our final example. Let's use and find Livermorium on the periodic table in period 7, P4. Highlight all of the elements to the left in the same period as Livermorium. Find the noble gas, radon, from period 6, the row above, and write Rn. Francium and radium on the left, and so we write 7s2. All of the electrons in the F block, which is filling 2 periods above the position in the table, so for Livermorium we have 5F14. Follow along in the D block for 1 period above, so we have 6D10. As expected, the final electrons are in the P block, where we write 7P4. Radon, 5F14, 6D10, 7S2, 7P4. While there are about a dozen exceptions to this rule, hopefully for each set of coordinates on the periodic table you can get a good start on writing down the electron configuration. We hope to post a video for each configuration, including the exceptions, and if you find these videos helpful, please let me know in the comments down below or consider giving them a thumbs up or becoming a subscriber.